Welcome back, and we're moving on. We are now at the grade 12 slot, and we're looking at chemical equilibrium. Now, chemical equilibrium. What is chemical equilibrium? When can we begin to speak of a chemical equilibrium in a chemical reaction? Now, a chemical equilibrium is a state in a reversible reaction where the rate of the forward reaction equals the rate of the reverse reaction. So we're talking mainly about the rate. We're looking at how fast a reaction takes place. Now, how fast a forward reaction takes place should be equal to how fast the reverse reaction takes place if we are to say a chemical reaction has reached a state of equilibrium. Now, for us to get there, it means that we need to have a chemical reaction that is taking place in a closed system. Okay? So that you don't lose any of the substances that are being formed there. Even if one of the product is a gas that evolves, which can actually easily escape and into the atmosphere, you need to make sure that the system is closed. It must be a closed container, so everything happens inside there. There's nothing that gets in, there's nothing that comes out, and therefore you can be able to reach that state of chemical equilibrium. Okay. Now, chemical equilibrium, like I said, can only occur if a reaction is reversible. That's first thing, meaning that the products are also able to disintegrate chemically to form the reactants. Okay? Now, chemical equilibrium once more, we're talking about reversible reaction. In other words, you need to have a forward and a reverse reaction. And until the rate at which these reactions are taking place are equal, it's then that we can say the chemical reaction has reached a state of chemical equilibrium. That's the only time we can say we have reached a state of chemical equilibrium. Now, the other thing is that chemical equilibrium can only occur if we've got that reversible reaction and it is taking place in a closed system. Okay. Now let's have a look at the chemical reaction here. It's hypothetical. We're looking at A plus B equals C. We don't have a chemical called A or B or C, but we're just going to use this analogy to try and explain and show what we mean by chemical equilibrium. Firstly, the way this chemical equation is written, you will see here that arrow there is double-sided, meaning that it goes forward and it goes backwards. So it goes forward and it also goes backwards. Okay, so A and B reacts to give us C, but C can also disintegrate, break up to give us back our reactants, which is A and B. Now, if I've got a graph here perhaps to show how the reactants are reacting to give me the product. We know we're starting with A and B as our reactants. So maybe A and B are somewhere there. So that's A. This is perhaps the amount of B. Okay, and there was nothing for C. So this will be for C. When the reaction takes place, the amount of B should get lower. The amount of C, on the other hand, this is C, should be forming. Okay, can form maybe up to that point. And the amount of A will be coming down. And maybe I can have something like that. Okay, so from this point here, where I'm seeing some leveling up of the graphs, this is where a state of chemical equilibrium has been reached. Okay, that state of chemical equilibrium has been reached there. Okay, now you would see that because A and B were your reactants, when the reaction starts, their quantity decreases, like for A in that way, and the quantity of B being a reactant decreases, while the quantity of C starting from 0 increases until it gets to a point where it levels up. Now, Here's something about these graphs here for you to understand. We're going to look at another one that will help you to put those ideas together in a better way that will not confuse you. From this point, from T0 to T1, the reaction is taking place, and the rates of the reactions are not the same. We may see maybe A and B reacting faster, C reacting quite slower to get back to A and B. But when they get here, where the graphs showing the quantities in moles, maybe that's moles and this is time in seconds, levels up, it tells you that the amount of B, A, and C are not changing. And when it's not changing, it doesn't mean that the chemical, the reaction has stopped, but it means that as the rate at which the forward reaction is taking place equals the rate at which the reverse is taking place. So you don't have a change in the quantities of the substances involved in that particular chemical reaction. So in that case, you have reached a state of chemical equilibrium. And that's very important to understand. Not that the reaction has stopped, but a state of chemical equilibrium has been reached. See you in the next section.